Physically, they look like adults. They have the height, the voice, and the independence. Yet many will stand at the edge of a high dive and lean forward without considering the impact. Society treats 18 as a finish line. We grant the right to vote, the right to drive, and sign contracts, assuming that a mature physical frame is proof of a mature mind. This assumption overlooks the endocrine system, a network of glands that releases hormones. These chemical messengers travel through the blood to signal exactly when the body should grow, sleep, or react. This chart shows body and brain development from 12 to 25. Physical growth spikes sharply by 18, while brain development continues at a slower pace. This gap reveals a biological reality. The body is adult-sized, but the brain remains mid-construction. This process begins around age 12 with a sudden flood of sex hormones. These chemicals enter the bloodstream to completely reorganize the physical body. In boys, a surge in testosterone triggers rapid muscle growth and bone lengthening, and the deepening of the vocal cords as the body prepares for physical adulthood. In girls, estrogen and progesterone drive the onset of menstruation and the development of adult anatomical features, signaling reproductive maturity. By age 18, these hormones have built an adult-sized body. To the outside world, the transformation appears complete, creating a physical illusion of maturity. But while the physical exterior stabilizes and looks complete, the internal emotional landscape remains in a state of constant, high-speed transition. This diagram shows the brain's emotional center, the amygdala. Hormonal fluctuations make it hyperactive, flooding the brain with unpredictable reactions and mood swings. Meanwhile, the prefrontal cortex, the logic center, remains underdeveloped. It lacks the structural connections to regulate these surging emotions. A teenager has the emotional drive and physical strength of an adult, but lacks the internal braking system needed to manage high-risk decisions. Because height usually plateaus at 18, we assume growth has finished. In reality, the most significant neurological changes are only just entering their final phase. Between ages 18 and 25, hormone levels begin to stabilize. As the chemical environment becomes more consistent, the frequency of severe mood swings starts to drop. Watch as the prefrontal cortex finally fills in. By age 25, this logic center comes fully online, establishing the permanent connections required to regulate the amygdala's emotional signals. This 25-year mark represents the true biological baseline for adulthood. It is the moment when long-term planning, impulse control, and emotional stability become physically possible. Managing this 13-year transition requires a massive amount of metabolic energy. The body is essentially a high-demand construction site until the mid-20s. Protein and vitamins are the raw materials for this growth. A balanced diet provides the necessary fuel for cellular generation, while high-sugar foods offer no structural support for a developing brain. Deep sleep is equally critical. Growth hormones, the proteins responsible for tissue repair and physical development, reach peak levels of activity while the body is at rest. Physical activity introduces endorphins into the system. These happy hormones act as a chemical counterweight, neutralizing the stress and anxiety generated by the amygdala. The chaos and mistakes of youth are the result of a specific biological timeline. This 13-year process is the mandatory path to building a brain capable of navigating the demands of adult life. We have all witnessed the volatile shifts of adolescence, the sudden, explosive anger of slamming a door, or reckless stunts that seem to ignore every rule of safety. By age 18, society grants these individuals the legal status of adults. Physically, they often stand as tall and strong as their parents, yet they continue to make high-stakes decisions with very little regard for the consequences. This paradox is driven by the endocrine system, a network of glands that release hormones directly into the blood. These hormones act as chemical messengers, traveling through the body to dictate growth, sleep, and emotions. Between ages 12 and 25, they initiate the most dramatic biological transition of a human life, causing hormones to surge and pulse with intense irregularity. The biological difficulty lies in the timing. The growth curve of the body and the developmental timeline of the brain do not move in sync. One reaches the finish line long before the other. This means the chaotic behaviors we associate with teenagers are the direct result of a severely staggered biological construction schedule. Between ages 12 and 18, the onset of puberty floods the body with a specific class of chemical messengers known as sex hormones. In boys, the surge of testosterone drives rapid muscle growth, the deepening of the voice, and the appearance of facial hair. In girls, estrogen and progesterone trigger the start of menstruation and breast development, while beginning to reshape the body into its adult form. This phase moves with startling speed, often transforming a child's physical frame into an adult shell in just a few years. This rapid physical transformation creates an outward illusion of maturity, even though the internal systems remain highly unstable. To understand that instability, we have to look past the height and muscle and examine the internal neurological environment. This is the amygdala, the brain's emotional processing center. Because of the rapid influx of new hormones, the amygdala becomes hypersensitive and overactive during the teenage years. This hyperactivation triggers intense mood swings and sudden flashes of anger or sadness as the brain struggles to process the sudden chemical shifts. While the emotional center is flaring, the logical control center at the front of the brain remains dark. It is still under construction and lacks the necessary wiring to communicate effectively with the rest of the system. This front section is responsible for impulse control, the ability to plan for the future, and the capacity to distinguish right from wrong. Teenagers possess the emotional and physical drive of an adult, but they lack the biological brakes required to restrain themselves. This mismatch is the primary reason for reckless, uncalculated decisions. By age 18, physical growth typically stops. However, the internal wiring of the brain continues to develop in silence for several more years. As a person enters their early 20s, and massive hormonal surges of puberty finally begin to stabilize, which naturally reduces the intensity of mood swings. Around age 25, the prefrontal cortex becomes fully operational. This area acts as the brain's CEO, providing logical control and long-term thinking required for adult life. True maturity is a biological milestone reached at 25, when the brain's logic finally masters the body's emotion. This 13-year window is a high-energy biological construction project that requires specific external support to succeed. Supporting this growth requires a diet rich in protein and vitamins to supply the physical building blocks the body needs to build new tissue and neural pathways. Sleep is equally critical. Growth hormones, responsible for cell repair and physical development, reach peak levels during deep sleep, making an 8-hour window essential. Regular physical activity helps manage the stress of these changes by releasing endorphins. Endorphins are chemicals produced by the body that act as natural mood stabilizers and stress relievers. These 13 years of development provide the specific biological adaptation and rewiring required to forge a resilient, fully formed human adult.